Hello, this will be a shorter version of my previous video, diagram for a small 12-volt solar system. This video is for those of you who don't need or want my equations and the whys, the hows, or the proof or whatever, and you just want to see the diagram. So here we are, a 120 watt solar panel, 18 volts, and it can produce 6.7 amps. Now for the battery, a lithium iron phosphate battery. In this video, I talk more about why we need a battery and also why I've used a lithium iron phosphate battery in my other longer, more detailed video, but here we're just going to continue with the wires. That 4 to 6 square millimeter wires running from the solar panel connected to other wires that then go through this solar gland to keep things waterproof, of course, then through the roof, then to a DC breaker or a DC isolation switch, such as this one. It's very important that it's a DC breaker and not an AC breaker. So let's install it. Also, don't exceed its voltage or current rating. Next up, we'll install an MPPT solar charge controller. Don't wire the wires straight to the battery without going through this controller. As you can see, we chose one with a screen built into it. It can provide us with all sorts of stats, like how much the battery is being charged and the voltage of it, and more. Now, remember this. Always wire the battery to the solar charge controller before wiring the solar panels to the charge controller. Now let's look at where the wires go. The wires running from the battery will go to the BAT terminals, plus to plus, minus to minus. PV stands for photovoltaic, which refers to the solar panels, so plus to plus, minus to minus. As for the load terminals, I wouldn't use them. Again, I'd tell you more about it in the long video. This is what we've got so far. As you can tell, I've added a little cheeky fuse there, or two of them actually. Nah, there's nothing cheeky about it, they should always be installed. And as close to the battery terminal or busbar terminal as possible. You can, if you've got a bigger system or if you just think it looks nice, pull a wire from the battery, or the fuse, to this distribution block, or a cheap option, these bus bars, and then add fuses. But because we've got such a small system and are doing things cheaply, we're not going to use them. We're just going to wire the things to the battery terminals. We've only got one charging source after all. I'll show you another way how to do it cheaply and without using extra bus bars, but that's for later. The big fuse, 60 amp one I've got here, is an A&L fuse. But there are many more you can choose between, such as these, but I'm not going to talk about them much. I do so in the other video, let's just move on. So here with this first example, I've got 2 wire lugs on each battery terminal. That's fine, just don't let it become like this, because that's a bit overkill. Right, so we might only have one charging source, but we might still have several appliances. So then begs the question, how do we draw current from the battery and distribute it to all our appliances in a fused way? Why, with one of these of course. A fuse block. Get a high quality one if you can afford, like Blue Sea Systems, because the one on the picture here is crap quality to be honest. These are way safer. More surface area for the terminals and better quality internally. Perfect. As you can see, I've got a 50 amp fuse there instead, but the 50 amp fuse, 60 amp fuse, even a 70 amp fuse will all work fine with 16 square millimeter wire. With a 50 amp fuse, we're ensuring that this poor quality fuse block that I've used won't have more than 50 amps flow through it, because I don't trust these fuse blocks with more than that, even if it says it can handle 100 amps. Unless we're talking about a good quality fuse block. So, these are my appliances, the ones I'm going to use in this simulated system. For a 60 watt or 45 watt 12 volt fridge, I would use 4mm squared wire. If you think it sounds like too much, then watch my other video, or Google inrush current fridge. I would use a 15 amp or 20 amp fuse for this, depending on how high your inrush current is. A little 30 to 40 watt 12 volt roof fan won't need anything fancier than 1.5 square millimeter wire and a 5 amp fuse. This is quickly how you would wire your lights. 12 volt LED spotlights often have small wires attached to them. Wire it in such a way that all positives get together and all the negatives get together like this, and you got yourself a parallel circuit or a parallel wiring. This way each light gets 12 volts and the amps of all the lights get added together. Do not wire them in series like this. I talked more about it in my other video, but in short, they won't really light up. Parallel is the way to go. Also, add a switch. otherwise they'll shine forever, or until the battery dies, whichever comes first. You don't have to use a small switch, you can use one of these switchboards. I've said it before, but I'll say it again. I talk more about these in my other video. Now for that promised second example that doesn't involve wiring the MPPT SOTA charge controller's BAT terminal wires to the battery, but instead you wire them like this. If that feels really strange because you'd normally use a fuse block for your appliances that draw current, but you want to know how it works, then watch my other video where I talk about it. I open it up and show you what's going on inside. Now, lastly but not least, a battery isolator switch. In case you want to disconnect your system from the battery, like do maintenance or whatever. There you are. Oh, and also now add all your appliances and the fuses, of course, the ones I took away. Thanks for watching, and if you liked it and want more information about the system, consider watching the long video. It's the same system but explained in detail.